This is going to be part 4 of the series of tutorials for completing our solar system application. This is also the second one in stage 2, and by the previous part, which was part 3, which started stage 2, we attached canvases with 2 texts to each one of the planets. So we left off pretty much when we were copying the one from Mercury to Venus, from Venus to Earth, and so on. So right now, if I go through all the planets, each one of them has a canvas and a text above, a text below. This is achieved, of course, remember, by copying the canvas from one planet and going to whatever planet doesn't have a canvas, and then edit, not just paste, but paste special, pasted child, keep local transform, then of course changing, the wording, like, on Jupiter, and so on. Let's just face it towards the camera. Just a few things to point out before we move forward. The only little changes that happen, other than just copy-paste as child, is that on the Earth's moon, I found it beneficial to increase the size of the info font. It was 0.09 and I made it 0.15. This is totally personal taste because it just looked so small. It scaled itself to the moon, which is like, really, really small. And the other thing to point out is that when it comes to Saturn, the canvas is a child of Saturn container, not of Saturn sphere. So Saturn container by now should have 3 children: the sphere, the ring, and the canvas Saturn. If I tilt it towards me, you'll be able to see it. Uranus and Neptune are regular planets, so each one of them just has a canvas. So let's go back to the instructions. We are in a different part or a different stage of the instructions, which is time to add scripting. We're going to end up with 3 scripts which we're going to hand code: Rotator script, Solar Manager script, and Lookat script. If you haven't created one yet, you're going to create a My Scripts folder in your assets. I already did. And I already have the scripts because I already typed them. So in the videos, my aim is to go over them. And of course, you're going to either pause or stop the videos while you're doing the hand typing. We're going to start with Rotator script. And of course, you start... In this case, you're not attaching it to a specific planet because we're going to attach it to all of them. So the way Rotator script was created was by right-clicking somewhere in the empty part of the folder My Scripts and create, and then mono behavior script. And it just creates one. I don't need to create one because I have one already. Now make sure that you use exactly the same name with the same capitalization because, of course, its code will have to use its name as its main class. Let me open that script because I already did what it says in the instructions. I already deleted its default code and replaced it with my code. And what I want to do in this video is explain how that code works. Of course, this is assuming that you, either between parts 1 and 2, or you just paused and you just came back, you have typed all of this too. If you typed all of it, with or without, the empty lines that I got, it should end up about 37 lines, but a lot of them at the end are comments. So it's even less than, it's about 30 lines. So let's go over that code for Rotator script. First of all, as you know me, my first thought is, okay, what do I want this script to do? I want this script to do pretty much 3 things. Number 1, I wanted to make whatever I'm attaching it to rotate around something else, like the Earth rotating around the sun. Job number 2, I wanted to self-rotate, like the Earth rotates around itself, which is, how we get the 24-hour day. Job number 3 is I want it to be to listen all the time whether the trigger on either controllers was pressed, or while we're testing in Unity if the B key was pressed. And if it is, I wanted to pause the planet, but only from orbiting around the sun, so I can fly towards it and see what it says in its info and so on. This will be taken care of by another script showing and hiding the info. But if the planets were moving around the sun, I would be like chasing them just to see what it says. So I want to be able to pause them by clicking that left index trigger or right index trigger. So in order to do that, the only library we need is the Unity engine. Then, the public class rotator script should be written already if the name of the script is rotator script, capital R, capital S. Then declaring 4 variables, 3 of them public, 1 of them private. A public game object, which is who to orbit. In other words, this script will need to know, okay, if I'm going to rotate around someone, who am I rotating around? For instance, if it's most of the planets, they're going to rotate around the sun. A private one, which is a vector 3, is going to take this object that we're going to say, let's say the sun, and extract its position. For instance, the position of the sun is 0, 0, 0. Because rotation is always around a position, not around an object. So we're going to specify an object and then extract its XYZ position. Then, because not all planets orbit at the same speed and self-rotate at the same speed, it's going to be a public float that we can specify, like how fast does the Earth rotate around the sun, simulating a year. How fast does the Earth rotate around around itself, simulating 24 hours, and so on. Notice that there is no start in the script. There's only update. In other words, this is being checked once per frame. In other words, 72 times per second. What is it checking? First of all, it's checking who to orbit position. So it extracts the position. It goes, okay, so there's who to orbit, let's say the sun. What is its position? Now, you might say, why do we need to check it 72 times a second? The sun doesn't move. That's true, but it's especially for the moon. The moon does orbit around the Earth, and the Earth moves. So the moon will need to know at any point what is the position of its parent, of Earth. So this will be the center of orbit. Then, an if-else. If the OVR input get input raw button left index trigger, in other words, someone pressed the trigger on the left controller, or someone pressed it on the right controller, or while we're testing in Unity, someone pressed the B key on the keyboard. The only reason I chose B is because it's close to the bottom and center. In that case, we're going to say, okay, transform, which means the object that this script is attached to. Let's say we're talking about Earth. We're going to attach it to all the planets. So let's say right now we're talking about this script attached to Earth. Hey, Earth, you're transform. I want you to rotate around. It's a function built into actually not into C#, but into the Unity engine. To do rotate around, we need to tell it 2 things. One is who to rotate around, who to orbit position. In this case, let's say the sun's position. And then a vector 3, which we can specify with XYZ or do a shortcut. We can just say vector 3 up. What is vector 3 up? It means, you can see in the shorthand, if you look, it means not X, yes, Y, and clockwise. The 1 means positive or clockwise. And the 0 is the speed. So in other words, what it says is, yes, you're going to rotate around the sun, but with a speed of 0. Why is speed 0? Because the user is holding the controller. And then also around itself, vector 3 up means rotate around the Y axis. Remember, rotating around the Y axis, always think like a door or a revolving door. That's the way, planets rotate. And times self-rotating speed, because the planet will keep rotating, and times time.delta time. Now, there's an explanation about time.delta time here. I'll trying to make it really simple. If we want the planet to complete one rotation around itself in 1 second, that means that in 72 frames, it's going to complete 1 divided by 72. That's time.delta time. Time.delta time is the time that passes, or the portion that passes in 1 frame. So if the self-rotating speed is 3 seconds, it's 3 seconds times a 72nd of 72nd of a second. And that way, overall, it's going to be exactly like 3 seconds. Delta time is the completion of time in seconds since the last frame. And we can read that explanation later on. Else is the opposite of if. What is else? If the user is not pressing trigger, it's normal movement, the planet should be moving. So in that case, I'm saying, hey, Earth, I want you to rotate around whoever I told you to rotate around. It's going to be a rotation of around the Y. In other words, rotating like a revolving door or something like that. You're going to have an orbit speed times time dot delta time. In other words, you're going to complete, if I say, for instance, 1, it's going to be 1 times 1 divided by 72, which is, or the fraction, which is going to give me 1 second. I'm going to make it a little longer. And it keeps rotating around itself. This line and this line are identical because whether the user presses the controller or not, I want the planets to keep rotating around themselves even when the user holds the controller. That's the end of else. That's the end of update. That's the end of the class. So this script is going to be for all the objects, all the planetary bodies that move, which means all of them except the sun. So what do we do with this script? So after we wrote all this code, teacher will explain code, which of course I just did, and also try to do it in class if we have time. Once a script is complete, we're going to attach it to all the planets other than the sun. For Saturn, it's to the container and to the Earth's moon. So how do I do that rather than, dragging like 12 times? What I could do is something like this. I can make sure all of them are selected. I can do like this. Let me fold all of them. I can fold all of them to make sure I have them. The only one I'm going to unfold is the Earth because I got the moon inside. And then I'm going to hold, if this was Windows, I'm going to hold Control. If this is a Mac, I'm holding Command. And I'm holding and selecting Mercury, Venus, Earth, Moon, not its canvas, Mars, Jupiter, Saturn container, Uranus, Neptune, all of them. And then I can take the rotator script. Why can't I drag it to all of them? Oh, because I selected the sun as well. So again, let me do Mercury, Venus, Earth, Moon, Mars, Jupiter, Uranus, and Neptune. The Saturn container is a little different. It's going to show like, different components, but I can still add and drag the rotator script, and now I just added it to all of them. Actually, did I do it twice? I might have. Yeah, to the Saturn container, I think I added it twice. So remove. I'm going to go through all of them and make sure. So now Mercury has this script. Venus has this script. They all have that script and only once. I'm also going to go back to part 1 and reiterate something really important about Saturn. As you remember, Saturn has a sphere, and of course we're going to disable the sphere collider, but even more important, it's got a ring, and that ring is based on a torus which came with a capsule collider. Very important to disable or even delete that capsule collider, because if we don't, it's used. Let me enable it and do some editing. I want you to see how huge it is. This is going to prevent us from even entering the solar system. It's going to collide. We're going to collide with it. So definitely disable the capsule collider or delete it. You know what? I'm going to remove that capsule collider from the ring just in case. So it can fly through it, basically. Now back to the script. What it says is now that all of them need someone to rotate around. So I will select them again. Mercury, hold Command, Venus, Earth, Moon, Mars, Jupiter, Saturn container, Uranus, Neptune. I've selected all of them, and I can see that they all need to be told who to orbit, what's their orbit speed and rotator speed. Now, you can see that these mean that there's different values for each one of them. But some things are going to be very similar. For instance, other than the Earth's moon, I'm going to exclude that. So all the planets other than the moon are going to orbit the sun. And I could do it one at a time, but who to orbit should be the sun for all of them. And then for the actual rotating speed, I'm going to go for each one of them separately. The moon, its who to orbit is going to be Earth. And then there's a table that tells you exactly, once the script is complete, attach it to all the planets other than the sun. For Saturn, it's the container plus the Earth's moon. For each planet, in Unity, enter the following values to the public fields. As you can see, who to orbit, all of them orbit the sun except the moon orbits the Earth. And here's the orbit speed around the sun, whoever their parent is, and their self-rotating speed. So let's try to do that rather quickly. This we have to do one at a time. Mercury. Let me try to make this readable. Good. For Mercury, Sun and 3-3. While I'm doing this, I'm saying, of course, this is a simulation, because if this was the real thing, we would have to wait a year until the Earth rotates around the Sun. So we're speeding things up and so on. It's just for, like demonstration. Venus rotates around the Sun 4, -5. The reason it's 4 and -5 is because Venus actually rotates counterclockwise. The Earth. So all these numbers, of course, are not accurate, but they're kind of accurate in relationship to each other in reality. They're scaled. Earth 3-3. The moon has Earth as who to orbit, and it's 10-10 because it rotates rather fast and also around itself. Mars will be 3-3. And you see how I got the script, because I attached it twice, just making sure that it's attached only once. Who to orbit on Mars should be the Sun. And 3-3, this is a good thing that I'm going through them one at a time. Jupiter also has the script twice. Let me get rid of it. And Jupiter needs to be 4-4. I already did that. And Saturn container has the script only once. It has 4 and 6, 4 and 6. Remember, the script, the rotator, is around the container, so it rotates both, all its children. Then Uranus. I don't need 2 instances of the script. Sun 5-5, Sun 5-5, and Neptune, I have suspicion that I have the same thing. Again, just make sure that each one of the rotating objects has 1 instance of the rotating script with the correct 3 parameters in there. In this case, Neptune 10-10. If I save right now, look at what it says on step 22. Test in Unity. Planets should orbit and rotate and pause orbiting when B is pressed. They still self-rotate. If this works, we're going to continue to the next step. So let's see what happens. I can see it in 2 ways. First of all, I should be able to see it in my game window. If I play, I should see all those planets rotating. Here they are. But I will see it even better if in my scene window I switch to Y and I look at it from above with the sun in the center, and I can see all those bodies moving. If I turn on my gizmos, it'll turn on the icons, which are basically the canvases, and this will help me see them even clearer. When I get closer to the Earth, I can see the moon rotating around the Earth. And when I get the Earth back into focus by double clicking on it, if I press B, all the planets stopped. They are still self-rotating. You see how the moon still rotates around itself and the Earth still rotates around itself. When I let go, they are both rotating also around the sun. By the way, sometimes hitting B requires focusing or clicking once on the game window, and then the B works. If that worked, we are ready for the next step, which is creating the app manager. I call it Solar Manager, but we will do that on the next part. This has been part 4. I will see you in part 5.